You're live.
We are live.
All right.
You're live. We're live. I'm live.
It's a good day to be alive.
It's a good day to be alive.
Right.
It's a great day to be alive.
Hi, everyone. Welcome to Energility Connecting the Dots. I know you can't see it from here, but there's plenty of wind and brightness outside, all that renewable energy floating around us. So, with the increases in the cost of energy and the growing concerns for climate change and impact on the environment, renewable energy has been garnering a lot of attention and interest lately. So that's the focus of this month's webinar. And my name is Richard Alexu. I'm the Manager of Strategy and Business Development here at Energility. Nice to see you all. Before I turn it over to Justin, just a couple of quick items. Number one, the session will be recorded. You'll be able to find it on YouTube. Just go to YouTube and search for Energility, and you'll see our list of past webinars. Your microphones will also be muted, so any questions that you need to ask, just type away. Use the chat box. I'll be watching that as we're going through it. And as a matter of fact, while we're getting started, if you have anything on your mind that you want to make sure we cover or address, type it in now or at any time during the session, and we'll make sure that we do our best to cover it for you. And on that note, I'm going to turn it over to Justin Kale, our Director of Opportunity Development here at Energility. Take it away.
Thanks, Rich. I'm going to share our slide deck here on renewable energy. So we're going to connect the dots today. The big energy topic of renewable energy. Going to cover quite a bit of content in a short period of time. One of the things that we want to be mindful of is, sometimes the term renewable energy, people are really thinking about solar, they're thinking about wind, or they're thinking about something specific. And renewable energy is a pretty broad topic. So that's why I want to break down a little bit of the understanding, some technical nuance, but then also, think about how, that's great to talk about it, but, how does it get implemented? How do you get incentives for it? How's this all work in terms of
How do you connect the dots? Make it work.
Connect the dots.
How about that?
That's right. Hey, novel concept, right? So let's make sure that we are sharing here with our friends on the screen today. So thanks for covering the rules of the road. We've been doing this for a little while now and done this quite frequently. And as we look at conservation, we look at efficiency, at the end of the day, in order to live, work, play, we have buildings that do stuff for us or that, provide us shelter. We need some energy to be consumed to be able to, have those useful purposes. There's ways to get renewable energy to power those buildings. So again, renewable energy is kind of a broad topic. We got solar energy. Yesterday I was driving in northern Ohio. There was a lot of clouds, but there was a little sun peeking through. But there's always sun coming up, and in some areas of the country or some areas of the state of Ohio, there's even a fair amount of wind. Actually, one facility that I visited yesterday actually had 2 wind turbines attached to it, and they were working on
Spinning away.
Those were just up and running. Actually, they had a situation where their wind turbines had gone down. So we were talking about their energy use profile. And I asked a question about a couple of dips in their energy use that were pretty dramatic. And they said, oh, well, that was actually our wind turbines were online, but then they went offline. So our use on the bill spiked up. So actually well timed with our conversation here today. Geothermal energy, being able to use the ground. One of the things that's pretty constant when our water supplies that get pumped through the ground, you turn on the spigot and the cold water. It's cold whether it's 90 degrees outside or it's cold whether it's 15 degrees outside. Using that, the dynamics of the ground environment to be able to either reject heat or be able to move the heat from one area to another using a heat pump, and a well is, geothermal energy. There's a technology like fuel cells. We got biomass, being able to take, some sort of waste and being able to burn it to be consumed as energy in another source. Taking some of this energy and connecting it to, batteries, energy storage, or, even being able to create these little, what they call microgrids, being able to take energy and move it around within, one of the things that gets contemplated, I've heard talked about quite frequently is, all these EV cars on the road from an environmental standpoint and replacing, fossil fuel, gas, diesel cars. But also we have all these little batteries now that are plugged in at our homes or our businesses. How do you potentially, a wave of the future, maybe being able to take and use some of that energy that's in those vehicles, to offset, energy from the grid, at certain times of the day. There's, again, some of this stuff gets pretty complicated, complex, pretty steep, but it's also not necessarily the adopted technology of buildings that is primarily what we focus on. Combined heat and power, that's a system that takes, useful heat that you have. I know we've walked a couple of factories, a couple of manufacturing plants. They're just simply exhausting heat out, or they have some reason to be able to heat in their process. Well, at the end of the day, if it's going out the roof, there may be a way to reclaim some of that. And if it's enough volume of heat, you could spin a turbine that might make electricity for something else. So that's kind of combined heat and power. And, really these, one of the reasons we touch on all these is because when we start talking about connecting the dots with incentives or the economics, these are the way things are classified with the IRS's investment tax credit. And we'll talk about that a little bit more in a minute. So this is a little bit of a grossly small slide, but this is also to kind of give you a little bit of a snapshot. When you click on the link here in the slide later, you can see this is the tax incentives for businesses. This is a brief description of those technologies and the way the IRS explains it. So let's talk about how you and I explain it. Some of these technologies are, again, not necessarily for everyone. For example, combined heat and power at the bottom of our list. The old churches or houses of worship that we deal with, they don't have that situation. They're not cranking out heat 24/7, 365 days a year. Well, combined heat and power is not for them. School buildings, they don't have, reason to generate heat all the time. They got to put out some hot water for, restrooms, maybe some kitchens. Wouldn't necessarily always be a requirement. So, solar tends to become the focus, for a lot of buildings because it's an easily adoptable technology. It's been around for a while, and it's pretty simple to adapt to, building a roof, whether it's pitched roof, flat roof. Some of the older buildings we're in, like with clay tile roofs and decorative roof structures, you have some issues and can't adhere solar panels to those, but it's a little simpler. So, maybe if we think about comparing, well, why would somebody do solar as opposed to geothermal? Geothermal, it takes drilling wells. You got to have we've seen some clients, we've had a couple of clients even that have had bodies of water, flat ponds and stuff like that. Could potentially use something like that to reject heat or to be able to cool a building. But it takes a lot more technology to make that happen. Certainly in the state of Ohio, we have some hilly areas, some flat areas. Not every area has wind. Sun comes up and goes down every day in all parts of the state. Again, biomass, combined heat and power, fuel cells. Those are different technologies that aren't always applicable to different facilities. you know, and getting battery storage, is still a newer technology to be able to adapt with solar. And so, just simply using solar is a great way to reduce the impact of drawing electricity off the grid. And, the kind of separating some of the myths from the actual methodology and thought process, is let's look at the data. Again, this is a little bit of this graphic's available at the National Renewable Energy Lab, but this is a publicly available data set from, credentialed researchers. You can see here just, for, not to insult anybody's intelligence, but for obvious purposes, or, for obvious visuals here, we got a lot of sun down here in the southern part of the country, and not so much up here in Ohio. But the reality is, when we start looking at Ohio, when we start looking at what some of these numbers in the scale mean, in terms of how many kilowatt hours per meter squared per day, this is kind of equivalent to about 135 to 152 kilowatt hours a day is possible here in the state of Ohio. So if we just kind of breaking down the math a little bit, a typical solar panel is about a little over 20 square feet and could be anywhere from 400 to 600 watts. The reason why it's much more possible now in Ohio, we'll talk about again some of the incentives, but if we think about the way this technology has evolved, and I tell people anecdotally, one of the things that I find interesting about solar is I have a little calculator on my desk that has a little solar cell that was from when I was, I don't remember, maybe 6th or 7th grade. So this technology has been around for a while, but one of the things we've found as it's become more widely accepted and more widely adopted, the panels that are this same footprint from, a church that we consulted on a couple years ago had a system installed in like 2009 or 2010, and their panels were like 230, 240 watts.
I love this slide because inevitably the first time solar is introduced into a conversation, the response is most commonly in Ohio, really?
Yeah.
And yeah, really.
Everybody thinks of the days like we're having now where it's might be raining or foggy or cloudy, and there is sunshine in Ohio.
The technology can still harvest that energy. So
yeah,
love it.
Good point. So when you have the same technology that can produce double the amount of output that it did, and we do have some consistent sun, let's look at a couple examples. These are some snapshots of some projects that we've worked on with clients. It can go on a building that's got a pitched roof that's slanted. In this particular building, it doesn't have a real dense energy use inside it. So this isn't offsetting 100% of their energy, but it's a chunk of their energy is just simply using the south-facing roof. We were able to accomplish the goal that the client needed, and that's kind of what it looks like from the ground. Could they have put it on the east and west? In a couple of cases, yes. Obviously with shading and the trees, not so much, but it is possible with this type of building structure. The one thing I also wanted to mention is, when you put solar on a roof, one of the things that comes up in the design phase is, all of these vent stacks or the gables on the roof, those are all considerations for the design. So it isn't just simply, gosh, I have X amount of square feet, how much solar can I put on there? So there is some design detail that goes into that. This project's actually a really good example where, when we had done some preliminary work, we said, oh, great, you got a lot of roof space up here. Here's what the potential is. Fast forward, getting the client's buy-in on doing some energy efficiency work and including solar as part of the project. When we right-sized this, we actually found the way this building is structured, there's a set of beams, and the way the roofing structure holds the HVAC equipment, it was designed to be able to manage that additional load up there, and it's structurally built that way. There's just I-beams running down through the building in the ceiling of the top floor, third floor here. And so when we actually got an opinion from the structural engineer, their opinion was, hey, put a row of solar panels down the center of that beam, and then on either side you can put, some additional panels based on weight. And then they did a full study, and basically what they said is they came back and said this will be with all safety factors. I know, Rich, you and I work with engineers all day, every day, is, they always have that caveat of we want to make sure that everything is calculated and quantified, and then we have a safety factor. Right. So this is a good one to just highlight the fact that, again, it's possible on, flat roof. This one has, a little bit higher perimeter parapet wall. So that's why some of those panels are back away from the edge to account for some of that shading. But, structural design is an important part of the process. In addition to, that this project highlights, shading requirements. This property has a pretty good size bank of trees here along the south side. So those panels were removed back a little farther to be able to accommodate the fact that they didn't just say, oh, great, it's the south side of the building, we need to tuck those panels up as close as possible. Again, proper layout, spacing, not impeding on the HVAC equipment. So again, a couple of things to consider, safety boundaries, the edge of the building, somebody's going to have to maintain it. Somebody also has to maintain that HVAC equipment that's up on the roof. So safety boundaries around that equipment is important. Putting on south-facing roofs, sun's in the south at the most powerful all year long. And with the, kind of slide a couple slides ago, but doubling the output of a panel, the technology's improved to the point where you can put them on east and west side, and especially if you have the right amount of roof space with the right energy profile in operating the building, you can get a pretty good economic return for putting east and west panels on. And a couple of the roofs we saw had a lighter coating using two-sided solar panels. You can really squeeze another bit of juice out of those panels, or out of the electrical system. And then the system connection is not just throwing solar panels up on a roof. There's electrical engineering that has to go into it, looking at the size of the transformer, depending on which utility is serving that particular building. What we've found around the state of Ohio with the big public utilities and the co-ops and the municipalities, a lot of those folks are accepting of solar, just they have their own rules and regulations and such for getting things approved. And for a good example is one co-op actually has a requirement that at 100 kilowatts or 100 kW system, anything above that, they change the tariff rate or the utility rate. So it becomes much less advantageous to put in 150 or 200 kW system than it would be to put in a 95 kW system, as far as being able to generate the expected cost savings. And then there's other utilities that will simply say, as long as it's engineered appropriately, goes through our permitting process, we're fully willing to accept and connect that system onto the grid. Because while the system that we're talking about are what we call behind the meter, or they're at the client site behind their electrical meter, they still have to be approved by the utility. So one of the dots we connect, right, is finance.
Right.
So, again, you can say, hey, I got a certain amount of roof space, or I have a certain amount of electricity that I use. How do I offset that? And does it make sense for me to put solar on the roof as one way to do that? What we've found is these type of systems are somewhat linearly scalable, meaning, if you build a 100 kW system for $2.25 a watt, then, you build a 1,000 kW system, is it going to be that same price per watt? It'll probably be less than $2 a watt, but if you build a smaller system, maybe 10 kW, it might be, 240, 250 a watt. But I would say this is a good ballpark, budget numbers to say about 2.25 a watt.
Mhm.
Complexities again with structural design on the electrical side. Some of those elements might skew that a little bit. So that would tell us that a solar system that's 100 kW, and just kind of put that in context, the old 100-watt light bulbs, trying to give some equivalence, 1,000 watts. It's kind of what those little space heaters that we know nobody has those in their office, right? Those little space heaters that you plug in, or those pretty much anything that generates heat like that you plug into the wall is 1,000 to 1,500 watts. So that's kind of 100 kW is the equivalent of 100 of those 1,000-watt elements. So that type of system is going to be a couple $100,000. And so if we look at that type of a system, it's going to generate a kW every hour whenever the sun's up. And so on average, a 100 kW system here in Ohio, we're going to get about 130,000 kilowatt hours out of that. And if we use our typical avoided rate for the state of Ohio would be about 8 cents per kilowatt hour. That means a 100 kW system on a roof here in Ohio would save a little over $10,000 a year. So kind of going back a couple slides, $200,000 investment. Well, that's a 20-year payback. Well, what about KW? Some of these businesses, manufacturers, commercial office buildings, gosh, you throw the lights on, you throw the cooling on, you start turning on computers. Yeah, you got all that stuff coming on at one time. So you have a demand, KW. There is some reduction in that, but most people turn on the lights in the morning, fire up the computer, start occupying buildings before the sun comes up or as the sun's coming up. And so there's, not to get too much in the weeds because we're about connecting the dots here in this webinar, not doing a technical dissertation on solar, but the simple explanation of it is, sun's overhead at like noon. And so that's when your system's probably designed to get the maximum amount of energy out of it. However, that's not always the same time that a building has the peak energy usage. So point being, there is some demand avoidance, but it's not much. So a lot of times you won't find that in a calculation to be able to say, hey, that's just how much you're going to save to be able to identify that return on investment. What we do is we have learned over time from some projects, as well as some literature and studies and talking to folks, that you can quantify that. And so it may be 25% or so of your demand could be avoided by some solar, if there's a component to that. Again, that's more of a case by case, but it's, sometimes people look at it and go, well, that's the energy savings. Well, what about the demand savings? That's part of my bill too. So another thing to think about is not just, how much is the actual energy savings of it, but gosh, what if I don't have $200,000, or what if I don't have all this capital money to put up front? Well, it's not necessarily going to reduce your upfront cost, but it would help you avoid cost in the total calculation of the project, where the federal government has an investment tax credit that you get back at the end of the first year. So you get that system installed. We're kind of running out of time in 2024, but system gets installed in 2025, and then when filing the tax returns in 26, there's an investment tax credit that can be applied to that. And this is a little bit of a complicated slide, but it just highlights maybe a little simpler than most things, the complexity of the tax code. This investment tax credit, the base rate, had been declining, and then in 22 bumped back up to 30%. And it's on the books as being 30% now for another 9 years. So, and then it will eventually decline. But for purposes right now, there's a 30% tax credit that's available to, systems of all sizes that we typically see, less than 1,000 kW. Depending on whether the project is totally designed and built with a lot of American-made products, it could get another 10%. Or if that site location is in what's called an energy community, could get another 10%. Again, the point being, there are some elements to this incentive that allows for anywhere from 30 to 50% tax credit. Another byproduct of the Inflation Reduction Act got a lot of press when it happened in late 22, and then over the last 2 years, it's really taken the IRS time to modify their systems and update their documents and statutes and all of the governing language that goes into our tax code. But simply put, the organizations that are nonprofits, municipal governments, municipalities, those folks can actually receive that same investment tax credit through what's called the direct pay reimbursement. So it's kind of analogous to filing a tax return, or nonprofits are familiar with the Form 990 that represents all of your financials and essentially continues to solidify that you're a nonprofit organization. The IRS has a structure now set up for being able to file documents to be able to get that tax credit back. So again, it doesn't help with your upfront cost. There might be ways to finance either short term or finance this long term where there's a better cash flow proposition. Mm-hmm. But simply put, it's now an incentive that's available that otherwise wasn't available a couple of years ago.
But that could bring your long-term project costs down upward of 50% in the right circumstance. It's
right.
Significant.
Yeah.
Good.
And I'll give you a good example. A client that we're working with right now that is just winding up their solar project. They had a benevolent donor that basically said, "Hey, we recognize that it's going to take some time to pay for this project." So they said, "Great, you fundraise, 70% of it, and we'll cover the balance." That basically a short-term investment that they said, "Hey, we're going to ultimately give to this project anyway, but one of the ways we can best give is we'll cover the tax credit part of it, but we know you're going to get back, but it takes you time to build it, file it, get it back." So again, all of that economics plays out and makes your return much quicker and more cost effective. So didn't see any questions pop up, but as we wrap up with connecting the dots, solar is pretty easily adoptable technology. We just talked about some incentives with investment tax credit. The other thing that we didn't highlight much here, because this would really vary whether you're a nonprofit or for-profit company, is for-profit entities have depreciation expense that they have to account for on all of their assets, all their big capital assets. The current way the tax code is structured, it allows accelerated depreciation to happen on an asset like a solar system or a renewable energy asset. So that depreciation expense that's usually parceled out in the length of the life of the equipment is now allowed to be accelerated up into the beginning years and be able to claim some of that as part of your cost-effective, economic calculation. Being able to say, "Gosh, my project cost is $200,000, but I can get an investment tax credit of 30%. Great, let's take 60 grand off that. Okay, I can get bonus depreciation. I can accelerate that at 60% for the first year. Boom. Now I'm down." And we've seen a lot of these projects where the incentives will stack up when you're accounting for all of those things at less than 50% of the capital cost of the project, if there's the tolerance to be able to wait 1 or 2 years to be able to get some of those incentives through the right structures. So being able to make sure that all the incentives are evaluated and there may even be other things like, grants from the USDA or other, we've seen Ohio prop up a couple of incentive programs to provide some grants. So those things would also, draw down capital cost. So making sure that, it may be easy to adopt, still expensive, and there's incentives that are help driving that adoption of technology. And it's also good to get somebody involved. Energility, if you don't call us and you have another trusted contractor, making sure you get somebody trusted in early on to help with that design, make sure that there's knowledge about how to make it, function, but then also making sure that the incentives are lined up, because some of those incentives are even structured so you can't really spend money until you get your approval. So you want to make sure that you're getting all of the proverbial ducks in a row on the right pond, swimming in the same row. So,
speaking of ponds, you mentioned a few examples early on, but one that you didn't mention, I've seen a lot lately, is floating solar
oh, sure.
ponds. What can you tell us and our reader or listeners about that?
Sure. Well, it's it's another one of those things that's interesting, because much like roof space, there's lots of bodies of water out there. Many of them rural, but some of them, a good example is the first one in the state of Ohio, floating solar, up at the Delco water system just here north of Columbus. Had a large body of water. The water company, well, that's space that they can't use for anything else, because it's the water. And so there's actually technology out there to help with buoyancy of keeping those panels afloat. The company that actually developed that, interestingly enough, they just had a project, because they're based down in the southern part of the U.S. They just had a project in Florida that actually they had some study done. It actually went through the hurricane, and actually as a result from the hurricane, they found that the system was still fully functional afterwards. And I don't know if it was minimal or maybe it was even no damage. So the fact is, the solar can float then on the water, and then there's designed anchoring system, so it's not just floating around like your paddle boat on a weekend, but it's attached and structurally adhered to the ground, and then it just sits there and floats. And again, space that would not be used for something else. A lot of times things on roof, I've talked to enough real estate folks that a lot of stuff on the roof is out of sight, out of mind. Well, that's not great if you have equipment up there that needs maintained. Everybody wants to keep that stuff maintained, but if you have a bunch of empty roof space,
Available space.
put some solar up there, and instead of writing a check to the utility company for his 3, 4, or 5 digits, maybe you're able to carve one of those off to generate your own power and get a return in a few years that it'll keep working, which I guess we didn't really touch on that. These systems are designed for 20, 25, 30 years, depending on the component level. And most of the reputable contractors will put in workmanship warranties, that are many years long as well. So you got a system that does require some minimal maintenance, but it's warranted for, 5, 10, 15, 20, 25 years, where you virtually pay no cost to maintain it. It's very, very small cost compared to the total life cycle.
And unless it's an
25, 30 years.
adjusting mount, there's no moving parts. So it's just taking in the rays and converting it.
Yeah, there's, which again, that gets into a technical detail, but there are tracking devices that would allow you to be able to track that sun. So it goes back to my statement a couple slides ago about the sun's overhead at a different time than you actually need energy in your building. Well, there's tracking devices that allow it to follow the path of the sun from sun up to sundown. Now that adds a moving part to it. So I have not seen those adopted in commercial or industrial buildings as much per se. But actually I was just traveling, I want to say down the southwest, maybe down near the Cincinnati area. It is not uncommon that you see those in large solar fields, because they're looking to build, they've got, acres and acres of solar deployed.
Every possible minute.
Yeah, they're looking to squeeze all the juice they can out of that. So, there's lots of ways that it can be adopted. It's, just a matter of what's right for each person and their business.
All right.
Certainly a way to get it done.
Yes. Well, thank you all for joining us this afternoon. We appreciate it. And we appreciate you coming to view our webinars on YouTube. Just go to YouTube and search for Energility and we'll be there. My email is richard@energility.com. We'd love to hear from you. If you've got topics that you want to hear in future sessions, or if you have questions about this one, just hit me up. Or if you'd like the slides from this or any of the others, again, richard@energility.com. We invite you to join us next month on December 19th. We focus on the third Thursday of each month for our webinars. And the focus next month will be on setting up a green team or a sustainability team within your organization. So how do we put some of these things into practice and organizationally make it work?
All right.
We look forward to seeing you all then. In the meantime, I hope you all have a happy Thanksgiving with you and yours. And thanks for joining us. Thanks, Justin.
Appreciate it.
Right. Take care, everybody.
And